Hello and welcome back. In this video we're going to continue solving linear equations. In the last video we did two different linear equations that both involve techniques like collecting like terms and distributing and dealing with fractions. And in this video we're going to continue doing examples that involve those types of techniques and scenarios. So with this first example we have 4 times 3x plus 2x plus 9 minus 5 is equal to 3 times 7x minus 5x minus 6 plus 2. And so again we got to decide how are we going to approach this question. Well, as I said before, we always collect like terms first and then distributes. So the 3x plus 2x becomes 5x and the 9 minus 5 becomes 4. So you have 4 times 5x plus 4 like that. On the other side you have 7x minus 5x, which is 2x, and negative 6 plus 2, which is negative 4, and so the left-hand side becomes 3 times 2x minus 4. Now that we've done that, we can distribute, so the 4 will be distributed to the 5x and 4, and the 3 will be distributed to the 2x and minus 4, like so. And so we'll have 4 times 5x plus 4 times 4 is equal to 3 times 2x minus 3 times 4. And then the 4 times 5x is 20x, and the 4 times 4 is 16. So you have 20x plus 16 on the left-hand side of the equation. On the right side, 3 times 2x is 6x, and 3 times 4 is 12. So you have 6x minus 12. And then from there, we want to rearrange so that we only have one x variable. So we are going to subtract 6x from both sides. The 6x and the negative 6x cancel out because 6x minus 6x is equal to 0. And so you have 20x minus 6x, which is 14x plus 16 is equal to negative 12. I'm going to rewrite it over here and then continue so things don't get too messy. We're going to then subtract 16 from both sides. So the positive 16 and negative 16 cancel out, and you have 14x is equal to negative 28. And finally, you can divide both sides by 14. The 14s will cancel out, and you'll be left with x is equal to negative 28 over 14, or x is equal to negative 2. And that will be your final answer. Okay, so we saw that this example involved two techniques that we went over in the previous videos, collecting like terms and distributing. And again, I'll show the color coding to help you visualize the distributing. So the 4 gets distributed to the 5x and 4, and the 3 gets distributed to the 2x and 4. Okay, so in this next example, we'll be dealing with fractions. And you'll notice in the previous video that we had one fraction for the second example. Now in this example we have two fractions. So we're going to be going over how to deal with multiple fractions. So as we did in the previous video, we looked at the denominator of the first fraction and just multiplied both sides of the equation by the denominator. So in this case the first fraction has a denominator of 5, so we're going to multiply the left hand side by 5, and therefore we're going to multiply the right hand side by 5. In this case we'll have 5 times 3x plus 2 over 5 plus 7 is equal to 5 times 2x minus 5 over 3. So this will give you 5 times 3x plus 2 over 5 plus 5 times 7 is equal to 5 times 2x minus 5 over 3. And the whole reason why we multiplied both sides by 5 is because the 5's cancel out. So we've essentially gotten rid of a fraction, because I said before, we always want to get rid of the fractions because we don't like them. They just make things complicated when it comes to solving linear equations. Okay, and I'll show you the distributing, because you'll notice that the 5 actually got distributed to both terms in the brackets. It got distributed to the 3x plus 2 over 5 and to the 7. So distribution works in the same way as it did before, whether or not you have fractions. Okay, so I'll rewrite our equation at the top over here again because I don't want things to get too messy. Okay, from here, so the 5's cancel out. That means that you're left with 3x plus 2 for that term. 5 times 7 is 35. So that's your left-hand side, and the right-hand side, you have 5 times 2x minus 5. Same idea, the 5 gets distributed to both terms. So you have 5 times 2x minus 5 times 5, and then over 3. So 2 plus 35 is 37. The left-hand side becomes 3x plus 37. And then 5 times 2x is 10x, and 5 times 5 is 25. So the right-hand side becomes 10x minus 25 over 3. And at this point, we still want to get rid of the other fraction. So we're going to do the exact same thing. We're going to look at the denominator of that fraction, which is 3, and we're going to multiply both sides of the equation by 3, like this. In this case, you'll have 3 times 3x plus 37 is equal to 3 times 10x minus 25 over 3. And once again, the whole reason why we did that is because we knew that the 3's would cancel out like that. And now we have gotten rid of all of the fractions. So again, I'll start at the top here and rewrite what we had from the other slide. So we had 3 times 3x plus 37 is equal to 10x minus 25, because as I said, we managed to cancel out both of the fractions. Okay, and then from there, you should be familiar with how to solve this, right? You do your distribution. So the 3 gets distributed to both the 3x and 37. You'll have 3 times 3x plus 3 times 37 is equal to 10x minus 25. And 3 times 3x is 9x, while 3 times 37 is 111. So you have 9x plus 111 is equal to 10x minus 25. And then, once again, we only want to have one x variable. So we're going to subtract 9x from the left-hand side, and therefore subtract it from the right-hand side as well. The 9x and negative 9x cancel out because they equal 0. 9x minus 9x equals 0. So you're left with 111 is equal to 10x minus 9x minus 25, or because 10x minus 9x is x, you'll have x minus 25. Okay, so I'll write it again over here, and then I'll add 25 to both sides because now we want to get rid of the negative 25. The negative 25 and 25 cancel out, and you're left with x is equal to 111 plus 25, or x is equal to 136. So you'll notice that x is a big number, but there's no restrictions on what value you'll get for x. It could be a decimal, it could be a fraction, it could be a large number or a small number. In this case, we got 136. So you'll notice that this example basically tackled everything that we went over. It went over dealing with fractions, it went over collecting like terms, it went over distributing, and it went over rearranging. So personally, I feel like if you can do this example, you can do any example. But that's why I showed it to you, because it really went over everything that we went over. And again, it might have looked like a lot. It's not because I'm trying to intimidate you, it's just because I'm trying to go over each of the steps carefully so that you understand everything that's happening. But if you were someone who had practiced it a lot and I knew was a lot more comfortable with it, then I could have summarized the steps like this. So our example again was 3x plus 2 over 5 plus 7 is 2x minus 5 over 3. And then I would have basically put all the steps in one page. So you'll notice this is everything that we did. It's just summarized. So we multiplied both sides by 5 first to get rid of the fraction with 5 as the denominator. And then after you simplify, you multiply both sides by 3 to get rid of the denominator of 3 and the fraction on the right hand side. And then once you do that, you just rearrange, collect like terms, and you get your answer. So please feel free to scroll through the video and the slides to take a look at the steps and get a better understanding of it if it helps. But those are the two examples I wanted to go over for this video. In the next video, we'll start looking at things like graphing, using the intercept method, solving standard forms of linear equations. But for now, that's all I wanted to go over. Thanks for watching.